Okay, so now we're going to more or less play around with a graph here to finish up this conceptual discussion of limits. Sorry. Okay, so remember with limits, we only care about what happens around x equals 3. We don't care what happens around it, and that's very important for you to keep in mind. We saw that we could create tables using tables to determine limits, and we saw that we could also use graphs to determine limits. It's tedious to use tables with graphs. If you graph it out, it's also tedious, but it might not be that accurate. So in the next lesson, we'll start to look at how to determine limits algebraically. But for now, let's play around with this graph I have here. And it's going to be very simple. Okay, so let's do some examples with this. Simple examples. You know what? Let's do it. You know what? Let me do it here then. Alright, so first question. The limit of f of x, okay, this is a graph of f of x. Limit of f of x as x approaches -2 from the left. See, don't know if you can read that. Let me write it bigger. So, the limit of f of x as x approaches -2 from the left. Right, that looks a bit bigger. Okay, -2, this reads 1, 2, 3, 4, 5, 6, hopefully. That was 3 and 7. Okay, so -2 from the left. Okay, it goes up to 5. Okay, now let's ask ourselves, what's the limit of f of x as x approaches -2 from the right side? Plus sign here. And the answer to that is 1. Okay. Next question. What's the limit of f of x as x approaches -2? Doesn't exist, right? Does not exist. And the reason for that is left-hand limit does not equal right-hand limit. See, they don't equal to each other. And the last question we can ask is, what is the value of f of x when x is equal to -2? Simple plug-in, take a look. 1. Right. And remember that this does not in any way affect this. Okay, if we can see this, there you go. Okay, let's do the same thing now, but with this thing here. Alright, so there we go. Let's work with this point now. Same thing. The limit of f of x as x approaches 3 from the left is equal to 4. Sorry about that. 4. Okay? Not a very good graph drawer. The limit of f of x as x approaches 3 from the right is equal to 4. Right. And therefore, the limit of f of x as x approaches 3. Notice that the left-hand limit is equal to the right-hand limit, and therefore, the limit does exist, and it's equal to 4. And lastly, f of 3 is equal to 6. Notice that we didn't look at this point at all when we did this limit thing. Why? Because we only care what's happening around x equals 3. Right, and lastly, let's work with this point here. Same story, almost. Limit of f of x as x approaches 7 from the left is equal to what? 1. Right? 1. The limit of f of x as x approaches 7 from the right. Do I have to write it out? Yeah, for sure. 7 from the right is equal to 1. Because the left-hand limit and the right-hand limit are equal to each other, limit does exist and it's equal to 1. But notice here that f of 7 does not exist. And the reason is that it's a circle here, right? And there's no dot anywhere else. Does it matter? It's undefined. No, it doesn't matter at all. It doesn't matter for our limits' sake. Okay, so that was a quick look at limits. Notice that limits do not exist when the left-hand limit and the right-hand limit are not equal to each other, but they do exist when the left-hand limit is equal to the right-hand limit. Okay, see you in the next lesson.